Hello and welcome to another video. We're going to be actually going through a t-distribution, which require two things that we should keep in mind. The first, the standard deviation of the population is unknown, and the number of the sample that should be less than 30. There is a person who is a CEO claiming that his managers are not reading enough. And typically, uh, in this situation, uh, we wanted to get the means for the population, which is 300 pages per week, let's say. And he assigned somebody to do the study. That person took 17. We don't know anything about the standard deviation for the population. And the sample is 17 people. So there was actually two requirements that actually clearly met the condition for the t-distribution. So this is the standard deviation of the population is not known, and the number of sample or the sample number is going to be is 17, less than 30. The mu, which is the mean for the population 300, the x bar, which is the calculated sample mean from the 17 people, turned out to be 289. And standard deviation for the sample was 725, so 25. So there is actually all the information that we need in order to calculate the t-score to compare it for the critical t-score is giving. I have the x bar, which is the 289. I have the mu, which is the 300. I have the s, which is the 25, of course, and is the number of the sample. I mean, how many people in this sample that they selected, the number in the people in the sample. We need to keep in mind something about the degree of freedom here, where we're talking about later when we're trying to find, actually, let me leave that as aside for a second. Let's delve directly into stating the null hypothesis, which is always going to be based on equality in this case. The mu they already told us that is equal to 300. How did we come to the conclusion this is mu is not equal to 300? The reason that the executive or the CEO said to us that his management are different from the other population or the other manager somewhere in the population. If he said less than, which we could easily do that, then the mu is going to be less than 300. If he said they're reading a lot more, then it's going to be a greater than. But obviously he has a problem with them. Either it's going to be different or less than. So we're going to leave it as not equal just to run it through the two-tail situation. So we'll be able to figure a similar problem, whether it's z or t or the proportion two tails. So let's go ahead and say here, what is the alpha? He said he's very confident. He actually could turn the test at 99% confidence level. So that makes actually alpha at 0.01. And in order for us to realize that 1 is going to be divided into 2, knowing this is not equal to, so you always divide alpha by two tails, it's going to be 0.005. Now we need to find the critical region, the t at the critical region. We're going to get two values for t, one in the positive, one in the negative. And you will see that critical region in a second is going to cover two areas under the bell curve, or similar to bell curve. It's not necessarily a perfect bell curve like we see it in the normal distribution with the t-square. But the larger the number of the larger of the number in the sample is going to be more, of course, like a normal distribution. So let's go ahead and do this for the probability distribution. I wanted to get the view probability. I'm going to actually do a different tiny little thing this time. Of course, I need to go ahead and change it from normal distribution to t-distribution and make sure now to get to the degree of freedom that I delayed the discussion of it. The degree of the freedom for the t distribution is really the number of the people in the sample, which is 17. We need to subtract 1 from that. So 17 minus 1 is going to be 16 as a result of that. And now we're going to go ahead and look at the shaded area. It's the probability. I could do this in the middle, or I could do it in both tails. I'm going to go ahead and shift to the both tails in order to highlight the rejection area instead of highlighting in the other one. I don't highlight the rejection area. It doesn't matter either way, you're going to get the same value, but I'm going to go ahead and do both tail for the rejection. In this way, I have only to give it one probability, which is really 0.01. Then it will actually do the work behind the scene. And in this case, we're going to get now the two values for t to where it's going to determine the rejection regions. And here we go. We got the 2.92. I'm going to go ahead and add it directly here, 2.921. 2.921. Obviously, this is going to be also in the negative as well. So it's going to be also negative 2.921. And that is going to be based on the calculated t, the t value, the calculated t value. And this is what we're going to be comparing. This resulted from this formula. Which is really what we call it, the t calculated value. And very easily we could go ahead and open parentheses using the rule of order. It's very critical. I made a mistake earlier. So it's going to be x bar, which is the mean for the sample, minus the mean of the population, divided, open another parentheses to guarantee that the order of operation is taken, it's in the right order. Then we're going to go ahead and look at the standard deviation for the mean, which is the S. It's going to be 25. That's mean 25 pages of reading within one standard deviation either way, divided by the square root, which is, this is a function in Excel. Again, you could use your calculator. You don't have to do any of that, which is divided by 17, which is the n, and close that. And we're going to get minus 0.8141. Which is immediately it's clear that this does not fall in the critical region. It does not fall in the critical region. So look here, this is the critical region. We'll talk about it. It's really to that minus 1.814 is a bigger value than minus 2.29, minus 2.21. Therefore, it's going to be here somewhere where I'm hovering my cursor. Therefore, that we're going to reject. We're going to reject. So the decision basically is going to be rejecting the null hypothesis, rejecting his claim that the reading is going to be equal to the 300. So there is actually a difference between the reading that his people and the actual population. So reject the null hypothesis. Oh, I'm sorry, sorry, it's actually not in the rejection region. I'm glad I caught this very quickly. So it's going to be fail to reject the null hypothesis, fail to reject the null hypothesis. And as a result, we need to make sure fail to reject the null hypothesis mean what? His claim is not correct. So people are doing, similar reading to what the other people in the population are doing. Again, this could be confusing. Like you see, we need to take our time a little bit to understand that if the the t calculated value is less than the critical value for the rejection region, then we have to accept the null hypothesis. Again, I'm having a problem with the word accept, but that's fine. It should be fail to reject the null hypothesis would be good choice of terminology. So let's go ahead and do that also through the t-test, which is going to emphasize this. I hope we have to get actually similar value to t. And I'm going to go ahead and click on menu tab. I'm going to go now to the stat, and I'm going to run the basic statistics. And I'm going to go to the sample t. Here we go. And I'm going to do the whole thing. Of course, I need to change. Okay, 1 second here. I added the wrong one, which is good to know. Catch it quickly. I'm going to go to the stat, basic statistics, and make sure that I have one sample t. Sample size is 17. The sample mean is 289. The standard deviation is 25. The hypothesized mean is 300. Now the option, it's still at 99 confidence level, and we wanted to actually make sure the mean is not equal because we wanted the two tails. And we're going to click here. Again, click on this one here. And notice we ended up with the same exact t, but more importantly for us to realize the b value is 0.088, which is way larger than the 0.005 for one of those critical regions for each side of it. This one here. So again, we fail to reject the null hypothesis. We cannot accept that. We cannot accept the hypothesis test or the null hypothesis. So fail to reject it because of the two things. Again, the p-value is too huge comparing to the 0.005. All right, it's not a huge, but it's much bigger in a way to that value 0.005. Sometimes you get probabilities like 0.6, which is way too big, but that's based on the data and the standard deviation and every other calculation. Thank you for watching. We're going to continue with the proportion, test proportion, which is going to be very interesting. Take care.